Welcome. Let us talk about this polymorphism second part, and we want to understand the multiple inheritance and the more dynamics in the polymorphic behavior of object. So in this discussion today, we like to talk about interface and polymorphism. Then the first thing is, it is very important to learn interface because interface makes our life very simple and comes into polymorphism. And take a look at this. What happens here? In this particular example code, we have a car, which is a car class, but that implements transporter. This implements is a keyword which we actually use to implement the transporter, but transporter actually provides a method called move. This move method is actually part of the transporter interface, and any vehicle, like whoever wants this interface, can implement this interface, and implements the advantage is that you can define the method, whatever method is written in the interface, you have to write all the methods. But the advantage is that implements can implement more than one interface separated by comma. Look at this here. We have a racer car class, and we actually say public void use transportation transporter interface. I'm actually passing as a reference, and then I call transport.move, and the move method is called. So interface spot the similarities. For example, you have two objects. What do cars and bikes have in common? What we see that move is common, and then maybe gears, change gear is common. So whatever behavior is common between the objects, we can pick all those common behaviors and form an interface. So interface actually spot the similarities. That's the concept comes here. So what do cars and bikes do not have in common? And if you see here car versus bike, we can understand the independent and the common ones. Independent car has radio, you can turn on and off headlights, turn on and off signals, lock and unlock doors. Bikes, you can drop kickstands, change gears, but move, brake and steer, these three are actually common spots, common interface between car and bikes. So, digging deeper into the similarities, what we say that move, brake and steer, how similar are they when they move? Do they move in the same way? Not very similar, because car drives and bikes pedal. So both can move, but in different ways. So we understood that the behavior, when we are looking at object, we are trying to find out common behavior. Those similarity, we will try to capture them as interface. So can we model this in the code? Yes, many real-world object has broad similarities. Car and bike can move. Car and laptops can play radio, phone, and there are many things. Objects are common. So take car and bike class. How can their similar functionalities get enumerated in one place? How can we bring the common behavior, the common function in one place, the common methods in one place? How can their broad relationship get portrayed through code? And what we see is that car and bike, both of them has move, brake and steer in common. Alright, so what we do is now we are actually talking about interface. Interface is a mechanism to create group of similar capabilities or functions of different classes together. Interface itself is a keyword in Java, and interface provides a mechanism to do multiple inheritance in Java. So interface model act as relationship. Like car and bike could implement a transporter interface. Transporter interface contains those three methods. So car and bike can actually come from vehicle, but they have implement different interface. This is called multiple inheritance in Java. So they can transport people from one place to another. They act as, whenever we say act as, means it is we are talking about interface. This act as, That means we are talking about interface. An object that can move, transporter, and have shared functionality like moving, braking, and tuning. And for this lecture, interface are green, like you see we talk about green. These are actually green color to represent. And pink is whoever is implementing the interface. Alright, so introduce interface. Interface are contracts that class agrees to. If a class to choose to implement the interface, it defines all methods. If classes don't implement one of the interface method, the compiler raises error because you cannot, that becomes an abstract method. Later we'll be discussing interface don't define the method, only define the name of the behavior. Interfaces only care about the fact that the method gets defined, and how to implement is totally on the class. So model similarities while ensuring consistency. Now, that means we are talking about interface is providing this common behavior which helps actually classes to implement their own way. So model similarities ensuring consistency. Let's break down into two parts: model similarities and ensure consistency. You can see model similarity. How model similarities while ensuring consistency, how does this help our program? We know cars and bikes both need to move. That is, should both have some move method. Let compiler know that too. Let's make transporter interface. What method should the transporter interface declare? Move. Because move is going to be implemented in car and bike. And only using a move for simplicity, but break, etc. would be useful. Compiler doesn't care how method is defined. As I'm saying, it will be defined in the class. It's just defined. So generative methods that interface should model functionalities of implementing classes there. Alright, so up to now we understand the model similarities while ensuring consistency. Declaring an interface, how does it look like? You simply say public interface transporter. Interface is a keyword. Declare it interface rather than class, but when you compile it becomes a transporter.class by default. And what you define a method, public void move, but no body, semicolon, just declaration. Second, the interface actually looks like declare method of contract. In this case, only method required move. And all class that sign the contract, that means whoever like to implement, must implement the move method. And take a look, interface are only contracts that class can be instantiated. Interface can only declare methods but not define them. And method declaration only semicolon, no curly bracket. So that's all, it's here. An interface is just like class. When you compile, you get a class file. So now public class car implements transporter, and the car class now implement the move interface, because declare the car act as transporter and implements transporter to class declaration. Promise the compiler car will define all the methods in interface, that is move. And ultimately, will this code compile? No, because you have to implement the move method, and never implemented move method and drive does not suffice. So you have to actually, error car does not override the method move. Alright, so we implement the method move now, honor the contract by defining the move method, and then this method signature must match how it is declared in the interface. That means they should be same. And finally, you include this method override, means you override the method which was declared and write in your own way what you like to do. It allows compiler to enforce and ultimately move explanation in the understanding of our discussions. So finally, we implement this transporter interface. In the move we are calling this dot, that means I have to write drive method, brake method, and drive method again. Move means you are actually driving, then braking and driving, so that's kind of thing we have shown. So defining interface method is defining any other methods, and it can be complex as simple. And let's modify car's move method by braking. So it happens to be like this. So what happens is finally, as with the signing multiple contact, class can implement multiple inheritance. You are allowed to implement more than one interface, create a colorable interface, and for example set color, get color, and you can implement transporter and then comma separated colorable. That means you can implement multiple inherit in multiple interface. But please remember one thing: every interface has a method definition. You have to implement all those methods. Even you don't do anything, just open bracket and curly bracket means it's actually empty body, but that you have to write also. All right. So class implement interface must actually look at this code again. Class implement interface must define single method, and a TopHat question is that which statement of this program is incorrect. Take a look. Public interface colorable, but it's a body, cannot be, right? Public interface colorable, public color, it's the interface, but you're defining the method body is not allowed. Public class implements colorable, and then get color, return color, public color, get color. So you are actually overriding the method. C seems correct. So given the following interface, which of the following would work as an implementation of clickable? Clickable is the interface defines click. So you know that you are going to actually override this method. The way it is written, public interface clickable public void click, but its public double click will not work. Public void click it will not work. D, public void click will work because it's exactly the same signature. That's what it is. So with this, we introduce polymorphism, and polymorphism again, many form, a way of coding generically, way of referencing many related objects as one generic type. Like car, bikes can have both move, refer to them as a transporter object. Phone tells, get charged. So these are all different forms of object in the polymorphism. And how do we write on generic use transport method? Motivation is many different kinds of transportation and possible, and how they move, and polymorphism-led programs sacrificing specificity for generality. So treat any member of class as their lowest common denominator, limited to method declaration, and we sacrifice, but you understand that polymorphism, what implications of this method declaration in parameters. For example, the method declaration is very important because use transportation will accept any object that implements transporter. You can see that. And we define these properties also in the interface. When to use polymorphism, using only functionality declared in the interface, or a specialized function using implementation class. If only using functionality from the interface is polymorphism. And practically, why use interface? Contractual enforcement will guarantee that class has certain capability. Class implements transporter, and it has a move method. Polymorphism can have implementation of agnostic classes and methods, and know that this capability exists and don't care when they are implemented. Allow more generic programming. And that's all actually why use interface. You can understand the summary. I will say that interface are contracts, cannot be instantiated, because this is actually like an abstract class. You cannot use abstract class to create an object. You cannot use interface to create an object. Force classes that implement them to define the methods. Polymorphism allows for generic code. Treat multiple classes as their generic type. Polymorphism plus interface is equal to generic coding. And why it is helpful? Want you to be laziest programmer that you can be. With this, we stop here, and we had a good understanding of polymorphism, interface, and abstract class. So let's enjoy, object-oriented programming.